ഹലോ എവ്രി വൺ, വെൽക്കം ടു വിന്നേഴ്സ് ക്ലാസ് റൂം. ഞാൻ രമ്യ. വിന്നേഴ്സ് ക്ലാസ് റൂം എന്ന ചാനലിലെ ക്ലാസ്സുകൾ നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ഈ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്തതിനെ സപ്പോർട്ട് ചെയ്യുക. അതുപോലെ ഈ ക്ലാസ് നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ലൈക്ക് ചെയ്യാനും ഷെയർ ചെയ്യാനും മറക്കരുത്.
Through this video, we are going to discuss 4 mark questions from the chapter Polynomials, Cbse grade 10. Okay, there is only one question in this video. This is the question. Rajesh donated some money and books which can be represented by the zeros, that is alpha beta, of the polynomial p of x is equal to 2x square minus 5x plus 7. Okay, anyways we have got a polynomial p of x is equal to 2x square minus 5x plus 7. Then zeros of this polynomial are taken as alpha beta, and this alpha beta will give you the amount or the money and the number of books which are donated by Rajesh. Okay, that is the thing which we got from the first sentence of the question. Now Akshita donated money and books in the form of a polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. Find the polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. That is the question. See, Akshita also donated books and money, but that is included here itself. That is, it can be represented by a polynomial. See, Rajesh donation from Rajesh is represented by this polynomial, and zeros of this polynomial will give us the money and books donated by Rajesh. Like that, Akshita's donation can also be represented by another polynomial, and what is given in the question is these two are the zeros of the polynomial, 2 alpha plus 3 beta and 3 alpha plus 2 beta are zeros of the polynomial through which we can represent Akshita's donation. Okay, so we have to find Akshita's donation, that is find the polynomial whose zeros are this one. That means we have to find the donation given by Akshita. Okay, we will represent it through a polynomial like this. And here we have already learned that if alpha beta are the zeros of the polynomial, then alpha plus beta is equal to alpha plus beta, sum of zeros of the polynomial is minus b by a. Right? Here in this polynomial, what comes in place of a? A is the coefficient of x square. Here it is 2. And b is coefficient of x, that is minus b here, and c is the constant term, that is 7 here. Okay, we are giving those values here. Minus of b is minus 5. See, that negative sign we should not avoid. We should take it with that negative sign. By a is 2. So minus of minus, it is plus, that is positive 5 by 2. Okay, thus we got alpha plus beta. Now alpha beta, product of zeros of the polynomial, that is c by a. Right, here c is 7 and a is 2. So we got alpha plus beta and alpha beta. And actually we have to find another polynomial which will represent the donation from Akshita. And we learned that a polynomial can also be represented like this: a constant k into x square minus sum of zeros of the polynomial into x plus product of zeros of the polynomial. Right? We have already learned it. So we are going to apply it here. That means we have to find the sum of the zeros of this polynomial. Okay, here the sum of the zeros means these two are the zeros of the polynomial. So we are going to just add it. This is the sum of zeros of the polynomial. Okay, 2 alpha plus 3 beta plus 3 alpha plus 2 beta. See? Okay, how many alphas are there? 2 alpha plus 3 alpha means 5 alpha. Now beta, 3 beta plus 2 beta, that means 5 beta. Right? Here 5 is common, so I am going to take 5 outside. What is left? Alpha plus beta. Okay, 5 times alpha plus beta is sum of this zeros of the polynomial. See, 5 times, what is alpha plus beta? We have already found it here. 5 by 2 into 5 by 2. Okay, so we got 25 by 2 as the sum of zeros of this polynomial. See, we are going to apply this 25 by 2 to this place. Okay, next we are going to find the product of zeros of this polynomial. Okay, product. We are going to multiply these two, right? 2 alpha plus 3 beta into 3 alpha plus 2 beta. Okay, we will just open the bracket. 2 alpha into 3 alpha. 2 into 3 is 6. So 6 alpha square. Alpha into alpha is alpha square. Now 2 alpha into 2 beta. 4 alpha beta. Okay, 2 into 2, 4. Alpha into beta, alpha beta. Now 3 beta into 3 alpha. 3 into 3, 9. Beta into alpha, again alpha beta. Okay. Okay. Now 3 beta into 2 beta, that is 3 into 2, 6. Beta into beta, beta square. See, this is the product of this polynomial. Okay, we have to rearrange it. Here we have alpha beta term. How many alpha beta? 4 plus 9, that is 13 alpha beta, and 6 alpha square plus 6 beta square. See here 6, here also 6, that means 6 I can take outside. 6 times alpha square plus beta square. Right? Now what is alpha square plus beta square? Okay, let us find it. For that we will use the identity alpha plus beta the whole square. Okay, we have learned the identity. A plus b the whole square is a plus b the whole square is a square plus 2ab plus b square, right? We are using it here. Here in place of a we have alpha and in place of b we have beta. So it is alpha square plus 2 alpha beta plus beta square. Right? Now actually in our calculations we got an alpha square plus beta square term here. Right? Here. So we are going to find what is alpha square plus beta square. Okay, so alpha square plus beta square is alpha plus beta the whole square, and this plus 2 alpha beta is taken to the other side of the equal to symbol, right? Now it is with alpha square plus beta square, but now I am going to take it to the other side, means it will become minus 2 alpha beta, plus will become minus when it goes to the next side of the equal to symbol, right? So alpha square plus beta square is alpha plus beta. What is alpha plus beta? We have already found it. Yes, alpha plus beta was already calculated as 5 by 2, alpha plus beta. So I am going to give that value here, 5 by 2 the whole square. Okay, then minus 2 alpha beta. Alpha beta is 7 by 2. Okay, thus we will get this alpha square plus beta square. Okay, this is equal to 5 by 2 the whole square means 5 square by 2 square. 5 square is 25 and 2 square is 4. Minus this 2 will get cancelled. what is left? 7 only. Okay, 25 by 4 minus 7. Now, yes, we have to do cross multiplication. Here there is no denominator term here. But here we have 4 in the denominator. So we are going to multiply this 4 by this 7. So 25 minus 7 into 4. 28 by 4. Now this is equal to 25 minus 28. 25 minus 28 can be considered as 25 plus minus 28. Here the bigger one is negative, so the answer is also negative. Then bigger minus smaller. 28 minus 25 is 3. So minus 3 by 4 is the value of this alpha square plus beta square. So let us apply this value here. Okay. So we were finding the product of zeros of this required polynomial. Okay. Product of zeros of the required polynomial. 13 alpha beta. What is alpha beta? Yes, we have already calculated it as 7 by 2. So we are going to give that value here. 13 into 7 by 2 plus 6 into alpha square plus beta square. Now we have just arrived. See, minus 3 by 4. Okay. So 13 into 7 by 2. Here 6 into minus 3. See, a positive number when multiplied by a negative number, the result will be negative. So here it is. And here 7 into 13 is 91. 7 into 13, 91 by 2 minus 6 into 3, 18 by 4. Okay. Here we have a 4 here and here we have 2 as the denominator. So what we will do? We have to equate. See, all the fractional parts should have the same denominator. Then we can do see this subtraction very easily. So we are going to just multiply this numerator and denominator by 2. Okay. 2 into 91 is 182 by 2 into 2, 4 minus 18 by 4. See, now we have got two fractions with same denominator and there is a subtraction here, means we can just subtract the numerators directly. 182 minus 18. It is 164 and we have 4 in the denominator. 164 by 4. What it is? See, in 16 how many 4s are there? In 16 we have 4 4s and in 4 we have 1 4. So 41 is the product of the new polynomial. So we got the product and sum. Now we are going to just apply it over here. See, we were just finding Akshida's donation as a polynomial, right? That was the question. Anyways, this k is there and x square minus sum of zeros of the polynomial is, yes, 25 by 2. 25 by 2 into x plus product is 41. Okay. Now, see here we have a 2 in the denominator. We can just multiply each and every term by 2. Okay. Then again we can say k. K is here. See, 2 into x square. 2x square minus 25x plus 82. See, this is the required polynomial. Okay. For convenience, we can avoid this constant term. Okay. 2x square minus 25x plus 82 represents the donation by Akshita.